Hello everyone. Let's talk about the graph of a quadratic function in the form f of x is equal to ax squared plus bx plus c, or f of x is equal to a times the quantity x minus h squared plus c. Here's the graph of a quadratic function. This one. We have three figures here. Figure number 1, number 2, and number 3. These are called parabolas, which are the graph of the quadratic function of the form f of x is equal to ax squared plus bx plus c, which is in general form, or it may be written in standard form or vertex form, which is f of x is equal to a times the quantity x minus h squared plus k. So let us try to identify now the different parts of the parabola in the Cartesian plane given a function. So we have to familiarize the different parts or characteristics of the parabola, and so that it will be easier for us, whatever the forms of our function, to identify the parts of the parabola in the Cartesian plane. So let us have the different parts associated with a parabola. So we have the parts or the characteristics of the parabola. We have the vertex, we have the opening, we have the x-intercept, the y-intercept, the axis of symmetry, the range, and the domain. So when we say the vertex, that is the maximum or the minimum point of the parabola. When we say the opening of the parabola may either go downward or upward. And the x-intercepts, these are the points where the parabola passes through the x-axis. And when we say the x-intercept of the parabola, it is the points that it crosses the y-axis. The axis of symmetry, that is the vertical line that divides the parabola equally into two equal parts. Then, the domain is the set of real numbers, and the range are all the possible output values of the given function. So we have here the parabola. We have three figures here. Let us identify the different parts. First, the parabola has a vertex. What is that vertex? When we say the vertex of the parabola, that is the maximum or the minimum point of the parabola. So in this figure, letter A or figure number 1, our parabola has its minimum or lowest point at the vertex. The vertex of our parabola is located at 0, 0. So this is your x-coordinate, that is the y-coordinate of the vertex. Then, for the second figure, our vertex is at the maximum since our parabola opens downward. So when we say maximum, it has its highest point here. So it is at maximum point of the parabola. Maximum point at the vertex, which is at 3 and negative 2. Negative 3 and negative 2. That is the maximum point. This one, this is the lowest point of the parabola. So, in other words, the parabola is at its minimum point. For figure number 3, the parabola has its maximum point at this point. That is the vertex, which is at 6 and 1. 6 and positive 1. So, that is what we mean by the vertex. The lowest point or the minimum point and the maximum point when it opens downward, and it has its minimum point when it opens upward. Okay. Next, the parabola has an opening. Okay, opening. When we say opening, we just have two, upward and downward. So in figure number 1, the parabola opens upward. Figure number 2 and number 3, it opens downward. How do we determine if the parabola has an opening which is downward or upward? If we have a function, given a function, our parabola opening is determined by the value of our a in the function, which is the coefficient of the quadratic term. So if our a, the value of our a is positive, then the parabola opens upward. If the value of our a is negative, then the parabola opens downward. So that is just how easy to identify the opening of the parabola if you are given a function. Next, our parabola has x-intercepts. X-intercepts are the points when our parabola passes the x, this one, passes the x-axis. So if we are given a function, we can solve for the x-intercept by letting the value of our y be equal to 0. But in this case, if we have the figure here, if we just look at the figure, the x-intercept of the first parabola is this point. This parabola passes at x-axis at this point. So, how do we write the x-intercepts? So, the x-intercepts is equal to zero. That is equal to 0. It passes through this point only once. So the x-intercept, we might only have one intercepts of the given function. But how about number 2? The parabola opens downward and it has its vertex below the x-axis. And the opening is downward. So, it never crosses the x-axis. So, therefore, this parabola has no x-intercept. It never touches the x-axis. But for figure number 3, our parabola touches the x-axis how many times? Twice. So, how do we write the x-intercepts of this graph? So, the x-intercepts are the set of points it touches at this point. 5, positive 5, and 7. So, it touches the x-axis twice or at 2 points. And then, for number 1, it touches the x-axis at 1 point. This is at 2 points. And this is at no point at all. Okay? Then, we have the y-intercept. The y-intercept is the point where the parabola crosses the y-axis. That's why it's called y-intercept. So, it is the point where this parabola will cross the y-axis. For figure number 1, this parabola crosses the y-axis. This is your y-axis at point 0. So, you have to look at the y coordinate or y value of the points or the ordered pair when it touches a certain point in the y-axis. So at this one, our y is equal to 0. Then for figure number 2, we have this one. If our parabola will continue to extend downward until it reaches a certain point where it touches the y-axis, then it crosses the y-axis once. Okay, but we cannot identify from the figure, but we know that it will cross the y-axis at a certain point. How about this one? This graph will also cross the y-axis at a certain point when it will continue to be extended downward. So that's it. So the y-intercept can be solved if you have the quadratic function by letting the value of your x be equal to 0 and solve for the y-intercept. Okay, but here we are looking only at the graph. So that's what we mean by the y-intercept. Next, we have the axis of symmetry. So when we say axis of symmetry, that is the line, the vertical line that divides the parabola into two equal parts. So for figure number 1, the axis of symmetry is this one. The graph is being divided twice. So that is the line. It passed through the x-axis at this point. So the equation of the axis of symmetry is x is equal to what point in the x-axis will this line passes through? It is at 0 point. So the equation of the axis of symmetry is actually equal to the value of x when your function is in the vertex form. That is the equation of the axis of symmetry, which is equal to the value of your h, or which is, in other words, the x value of your vertex. So you just have to look at your vertex. That is the equation of the axis of symmetry, which is at 0. So in this case, x is equal to 0. For the second figure, the equation of the axis of symmetry here is, this is the line. Okay, it passes through the x-axis at point 3. So your x value in your vertex, that is the equation of the axis of symmetry. So x is equal to -3. Okay. For the third figure, we have the equation of the axis of symmetry. The line that divides the parabola into two is at x is equal to, what is the value of your x in the vertex? That is at 6. So that's the axis of symmetry all about. Then we have what we call the domain. The domain is always equal to the set of real numbers, the value of our x, because we cannot input anything other than the set of real numbers in a given function. So we only have to see or set values of x, which is found in the set of real numbers, to get the output. Okay. Then the last one, we have the range. The range is the output, the possible values of the function when an input is given or the domain is given. That is from the set of real numbers. So in here, how do we write the range when we look at the graph in the Cartesian plane, just like this one? So when we write the range in symbol, we just have to look at the y value in the vertex, which is the minimum or the maximum point. For number 1, our range here is written as the graph opens upward. So these are the values of the range which is equal to or greater than 0 because the graph opens upward. These are all the possible output of the function. This one, the values above the graph or within the vertex, and which is 0 or greater than 0. So we write the range as the values of y, set of values of y such that y is, since that opens upward, so the values above this value above 0 are numbers greater than 0. So y is equal to or greater than 0. So this is how we write the range. For the second figure, our range has its maximum point in here. So the set of values for the range are the numbers -2 and below. So we write the range as the set of y, the values of y such that y is, since our graph opens downward, so that means less than or equal to -2. -2 is included, so that is why our range are the set of values of y such that y is less than or equal to -2. Then, for figure number 3, our range is written as the set of values of y, in this part, y such that y are the numbers or values which is equal to or less than because the graph opens downward, less than this one, the highest point, +1. So that is how we write the range of the function. In here, let us try to identify the parts and characteristics of the given figure, which is a parabola. So, let us try to identify the vertex, the opening, the axis of symmetry, the domain, the range, the x-intercepts, and the y-intercepts. So first, we have the vertex. The vertex is located at this point, which is at point, our vertex is at point 3 and -2. So we have 3, our x value is 3, and our y value is -2. So that's our vertex at 3 and 2. Next, we have the opening. The opening is upward. Okay, we have upward, our opening. Then, the axis of symmetry. The line that divides the parabola into two equal parts is what we call the axis of symmetry. So, in here, our axis of symmetry is this vertical line that passes through the x-axis at point 3. So, the equation of the axis of symmetry is x is equal to 3. So, the line passes through this point. Then, we have the domain. Our domain is always the set of real numbers. And our range, how are we going to write the range in symbol? So, our graph is at its minimum point at the range which is -2. So, that's the lowest point. So, when we write the range, we have now the value of y such that y are numbers. This is the lowest value. And then, your parabola opens upward. So, therefore, the symbol that we are going to use is y is greater than or equal to -2. So, that is how we write the range. Then, we have the x-intercepts. The x-intercepts are the points in the x-axis that the parabola will pass through. So, in here, our x-intercepts is at this point. So, how do we write that one? X-intercepts is equal to, that is +1 and +5. That's our x-intercepts. Then, our y-intercept, opposite to the x-intercept, that is the point where our graph or the parabola will touch at point 2. So, y is equal to +2. So, that's just how to write the different parts or characteristics of a given parabola. As short as that.